All right, just to recap for today. Random sampling is something that you use to figure out the size of a population when certain conditions are met. Now, the two most important ones are the first and the last. Now, this one in the middle is sort of, but this is for sure going to be used if, one, the population doesn't move. So anything that stays in place that you can count today that's going to be there tomorrow, you can use random sampling on. Or if they're microscopic, because there's going to be so many of them, you're not going to be able to count them by hand, or it's going to be very, very difficult to use this method or direct counting or mark and recapture, which we'll talk about later. The other condition that you'll kind of want to meet is usually you have a small number of organisms in a relatively small area. Like when you decide on picking a square, okay, so you decide, okay, I'm going to count how much is inside of this square. You want to make sure it's a relatively small number. So typically nothing more than 500 inside of a 1 meter square area. But again, worry about the first two conditions. Those are the most important. Now, inside of your notebook, you have this page here. I'd like you to write, see page blank for a better version. And then what I'm about to show you in a little bit, I would like you to redo this section of the notes. This is a math problem. So yes, there are multiple ways to solve it. This is one way, but I think there's a better way to do it. So here, I just need you to do the top part. So on a kind of a brand new page, I need you to copy this down. I'll explain this. If you feel like drawing it because you feel it's going to help you out, that's fine. But this part kind of explains all the pieces. So go ahead and put it on pause. Take care of it. All right, hopefully you're done writing that. So over here, just some variables so you can keep track of what's what. Big N equals the estimated population. That's what we're looking for. Big A is the total area of the population. So typically if we are measuring something out at the beach or in a particular area of the ocean, we have this huge area and we don't want to measure the entire thing. So let's just take this field right here. Let's just say we wanted to count how many flowers are in this field. Like you can't even see them, you're so far away. But you don't want to go and count every single flower in this field. That's what random sampling is for. So you're only going to go and sample a few of these squares. Now the question is, okay, how many? Because like one is not going to be enough. Typically what you want to do is you want to get about 10 to 15% of the total area. So if there are 100 squares, which there happen to be here, you're going to want to go out and sample at least 10 of them. Probably 15 to give you a better number, but you're not going to want to go and count all 100. So coming back to this, if that grid that I just showed you as an example, big A would be 100 because there's 100 total squares. The sample area size is, okay, well, how many are you going to go sample? Like I said, you want about 10 to 15. So let's go back to our example. All right, and here I'm going to pick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that would be my sample area size. Now, how do I know which ones to pick? That I'll cover in class later. So here we go again. Big A would be, okay, what's our area size? 100. What's our little a? Well, that would be 10 because we're sampling 10 times, and then little n is the number of individuals in the sample area. So just to make that clear with the samples. So like right here on this sample right here, I have 12 squares total. So my big A is 12. I'm going to go and sample 3. That's why I highlighted 3 of them. That's my little a. Now, how many are inside of the highlighted squares? So those 4, 5, 6, 7, 8. Now I pop it into my equation. 12 divided by 3, in parentheses, times 8 will give you 32. Now there's actually 30 dots in here. Well, you're saying, well, that's the wrong answer. No. Again, this isn't estimated. It's saying there's about 32. Well, that's pretty close to 30. All right, what about this one right here? So big A would be how many squares, how many big squares total? Well, we have 5 across, 5 down, so that's a total of 25 squares. I don't want to sample 25. Little a, how many did I sample? Well, in this case, 1, 2, 3, 4. I sampled 4 squares. So big A would be 25. Okay, 25 divided by 4 times, well, how many dots are inside the sample area? Well, I can see there's 4, 5, 6, 7, 8, 9, 10, 11. There would be 11. So again, you're taking 25 divided by 4 times 11. Now, this is going to give you a number of 68.75. Now, there's no such thing as a 0.75 animal, at least if it's alive, so we're going to round this up to 69. Now, if it was something like 68.3, you would just call it 68. All right, so a couple more sample problems. So here's Monterey Bay. Let's just say we wanted to go out and we wanted to sample how much plankton is out there. Well, since they're microscopic, this is the way to go. And we're going to do this by weight. So you can also, not just by individuals, but you can also do this by how heavy it is. So we go out and we sample 3 squares. Now this one is, we should have more, but just for the example, let's count them as 3. Now, how many squares are there here in the water? Well, there's 350. You don't need to count them. I counted them for you. If you want to put it on pause and count them, be my guest. So, well, let's plop it into the equation now. All right, so using that data, so what did you count? Okay, well, we counted 7 kilograms, 8 kilograms, and 9 kilograms worth of plankton. And I'm sorry, this should be 3, so I got to make a quick change here. Because there was 3 sample areas, see, 1, 2, 3. And they were all 1 meter squares. So how many kilos, so let me rewrite this, how many kilos in a 350 square meter area? Well, 350 is our total area size. How many did we sample? Well, 3 1 meter square areas. How much was in their total? So this is where you take these kilograms, you add it together for 24 kilos, or like it would be 24 trees or whatever. And then what would the total weight be? So we would ask, what would the total weight be? It would be the 24 kilos. You would have the 3 square meter areas that we measured, and then a total of 350. So when you plop that into the equation, it's 350 divided by 3 times a total of 24 kilos. All right, so for the final piece of this, and you can put it on pause, I'm going to need you to answer these questions. It's multiple choice. So for number 1, I helped you out with, okay, here's the big area, big A. I helped you out with little a. Okay, and just you can figure out the rest of the problem here. And then as I move through problems 2 and 3, you'll notice that there's less and less info. So here's problem 2. Go ahead and put on pause, work out the equation, fill out your variables, make sure you have an answer. And then finally number 3.